Okay, so today we're going to have a little fun with laws of logarithms. All right, so this is laws of logs. Okay, so law, not law, but law. Okay, all right, let's get serious now. So R8 is laws of logarithms. So the first one we have here is, you notice that we've got the bases are the same here all the way across. So you've got the log base A of m times n equals log base A of m plus the log base A of n. So pretty much what you can do is you could break up whatever's here into factors and then separate them and write them out as separate logs. So if I were to rewrite this as 6 equals 2 times 3, right? So I could rewrite it as 2 times 3, and then I could rewrite it so that I've got log base 2 of 2 plus log base 2, 3. Right, good. Okay, so we're just splitting it up. And now when we're looking at m over n over here, what we can do is we can take and we could separate them into 2 logs with a minus sign in the middle. Okay, so I've got 8 over 3, and they're going to be both to the base of x. So log x, what's in the numerator goes first, and then what's in the denominator goes second. Now this next one it comes in handy a lot, and it's probably my favorite one. Yeah, is the third one here. So notice how we've got an exponent here. This law allows us to bring down the exponent so that it multiplies in front of the logarithm. Okay? So I can rewrite this. Well, how can I rewrite square root 6? 6 to the 1/2, right. So I have log base 3, 6 to the power of 1/2. Now, this law allows me to take this exponent and write it out in front, multiplying by the logarithm base 3 of 6. That's my favorite one. Why? I don't know. It's cool. It comes in handy. All right, so now, yeah, we've seen this last one here before. We've seen number 4 before. It's coming back. It's coming back, right. So we use this a little bit at the end of chapter 7, I think, to solve one of the equations, I think. Yeah?
I don't know.
I think. Anyhow, so it's we change the base, right? So we're going to put it to base 10. So we write log, so what, yeah, 7 over log of 2. And now we can actually put that into our calculator.
Yeah, we did this like yesterday.
Yeah, we've done this one before. So when we put this into our calculator, we end up getting, so we could do something like, here, log 7 divided by log 2, and hang on, I messed up on my brackets here. So log 7, I have to close that bracket, divided by log 2, and then close that bracket. The problem before was that I left that bracket open. So this is 2.8. All right. So that's rounded to 3 decimal places. All right. So now the log button on the calculator is base 10. And so this button can only be used to find solutions to the equations with base 10. Some calculators are actually coming out with being able to enter in log, and then they've got a square and then a big square. Yeah, a couple of you guys have these calculators, but most of them don't. And so what we use is we use this in order to solve those, evaluate those questions. All right. So now the next question says, simplify the expression. And note, this is going to be something that's not in the calculator section because, well, there's really no numbers to deal with. We just have to rearrange this and simplify this so that we have one log and then an expression beside it. So what can we do with this? Well, we could take this. This is multiplying out in front, right? We can bring this up into the exponent there. So I can rewrite that as log x squared, this part right here. And then here I've got a minus, and let's deal with what's in the bracket. So log y, and then let's deal with this guy as well. So I can bring that up into the exponent. So log y minus log z to the 1/3. And then I'm going to close my bracket. How about I remove the bracket, multiply everything after this by negative, and then I can use the rest of my laws. So that turns into a positive. Okay. All right, how can I rewrite this? I've got z to the 1/3 is the same as the cube root of z. Okay. Now, how can I deal with these pluses and minuses that are in the logs? So anything that is being added together. So if I were to rearrange it like this, would this help you see it a little better? Because I can rewrite, you know what, I'm going to write it as a cube root there, and then minus log y. So which log law do you think we're going to use now? So the plus one, we're going to use this first one. And then for the minus, we're going to use the second one. Okay, so when they're being added together, where do they go? They go in the numerator, and they multiply, the arguments multiply together. So that's squared, and then I've got the cube root of z, and then that's over y, okay? So this is all to that one log there. Okay, now the next one says expand the expression, and I've got log base a, so it's all to base a, and then a square root c, those are being multiplied together, and then the b squared d, those are being multiplied together, right? But then I've got these guys in the numerator and these in the denominator. So you can kind of pre-think which laws you're going to use. So let's first separate them so that they're all adding and subtracting from the first two laws. So if I have log base A, capital A, plus log base A square root of c, and then to deal with these guys, which ones are we going to use? The second one, because they're dividing, right? So it's going to minus log b squared minus log base A d. Okay. Now I want to expand it as much as possible. So what can still be expanded here? I've got this square root, which means it's c to the power of what? A half. So I'm just going to rewrite this whole thing so that it looks a little nicer. So log a c to the 1/2 minus, and then I've also got another log with an exponent, right? So what can I do with those logs with the exponents here and here? I can bring them down in front. So log A plus 1/2 log C minus 2 log, forgetting my bases here, B minus log AD. Just make sure I got everything. Yeah. Okay, so then this is where you would end, because that's expanded as possible. Okay, so now this example 3, we've got some numbers that we're going to be doing exactly the same thing with. So simplify and evaluate the following expression using the laws of logarithms. So I've got the same base for everything, so that makes it nice and easy. Yeah, so I've got log base 6, and then these two multiply, and then that one divides. So I've got 8 times 9 over 2. Okay, and now I could deal with this argument here. So log, can I just reduce it here so I've got less multiplying to do? And then I've got log base 6 of 36. And now I need to think, okay, 6 to the power of what is equal to 36? So I'm going to keep this aside. So then that actually equals 2. So it evaluates to 2. Okay. So I could even just do this to kind of help it all be in line. Okay. That follows a little bit better. Because 6 to the power of 2 is 36. So then this evaluates to be 2. Okay, let's try the next one now. So we need to clean it up a little. So there's a bracket here. Yeah, so let's open that bracket up. And how about we take this too and we put that up in an exponent there. Okay, at the same time. We'll do a couple things at once. So I got log base 2 12 squared minus log base 2 6. And then can I take this and put it up as the exponent? Yeah. All right. And make sure I put a minus there, right? Because of the negative multiplying through. So I've got log base 2. Now 27 to the power of 1/3. What is 27 to the power of 1/3? That's the cube root of 27, so that's 3. Okay. So now this is going to be, and I'm going to evaluate 12 squared as well. So 144 minus 26 there, minus log 2, there, 3, there. Okay, now I can combine all of my numbers together into one log. So I've got one log, and I have 144 on the top here, and then where does the 6 and the 3 go? On the bottom. So I've got 6 times 3. All right, so now I can simplify what's here. So what does that simplify to? 144 over these, yeah, all of these have the same base. If they have a plus in the middle, I multiply them. If they have a minus, then I divide them. Okay? So that's why both of the 6 and the 3 are in the denominator here. Okay? So then this is log base 2, 8. And then I can think 2 to the power of x equals 8. So what is x in this case? So if I say that's equal to x, I can say x is equal to 3. So this evaluates to 3. Okay. All right. And this last page. So here we've got a couple of if statements. If log base A 2 is equal to 0.03, or sorry, 0.3, and log base A of 3 is equal to 0.48, and log base A 5 is 0.7, evaluate the following expression. All right, so we need to somehow break this up so that we end up with factors of 2, 3, and 5. And that's basically our approach. So what is 150 in terms of its factors? So it's 15 times 10, right? So let's organize. So 15 times 10, 5 times. Okay, so let's break it down to its prime factors. All right? So I have 2 times 3 times 5 times 5. Can I write 5 squared? All right, so now I can write log A 150. I can say that that's equal to log A and then 2 times 3 times 5 squared. Now, using the log laws, since these are all multiplying together, what can I do? Log A2 plus log A3 plus log A5 squared. Now, how can I simplify this? Log A2 plus log A3 plus 2 times log A5. All right. Now, we've got these down to what we're given in the question, right? Here's log A2, log A3, and log A5. So I can take these numbers here and substitute them. 0.30 plus 0.48 plus 2 times 0.70. And add them all up together, and what do we end up getting? So this is 0.78. So this is 0.78 here. Plus, and this is 1.40. So I end up getting 2.18. Yeah. And that's my final answer. All right. And then this part B that says log base A square root of 10 over 3. Now the whole 10 over 3 is under the square root. So I can actually, write that as a 3, write that to the power of a half. And then I could use which law is it? The third one? This is my favorite law, right? So I can rewrite it as 1/2 log A 10 over 3. Yeah, we can still, so now we have to break this up. So we can break it up as what? 5 and 2. So I'm just going to, because I don't have enough room, I'm just going to go on this side here. Log A, so 5, 2, and 3. Okay. Now, So I've got this 1/2 out here, okay? I could either put a big bracket around here and then split all of this up, or I can put the 1/2 on everything. Your choice. So let's put a big bracket out in front and then split this up. So log A5 plus log A2, and then minus log A3. Okay. Now, how did that work out? Okay? Are we where we want to be in terms of the simplification?
Yes.
Yeah, because we notice that we have these prime numbers that we had at the very top of the page, right? So 1/2, and then what is log A5? Point. What's log A5? 0.7? Okay. And what is log A2? And subtract 0.48. Okay. So what does this all equal inside here?
It's
0.52?
Yeah.
And then what's 1/2 of that? Okay. And then okay. And that's what this is evaluated to. Yeah. All right. And then here it says if log base A 3 equals 0.48, determine the value of A. So what are we going to do with this here? So, or we could rearrange it so that it says 0.48, a to the power of 0.48 is equal to 3. And then we could raise both of them. So I've got the power of 0.48 here, right? Now I can raise both of them to the same power of the reciprocal. So what happens to my exponent over here on the left-hand side? So if I've got 0.48 over 1, and then 1 over 0.48, yeah. So then I've got a to the power of 1 is equal to 3 to the power of 1 over 0.48. So then I'm going to need my calculator to evaluate this part. 3 to the power of 1 over 0.48. And I get 9.86285. So A is equal to or I could round it to 3 decimal places. Yeah. All right. We just need to round to, we're just rounding to 3 decimal places here. Yeah. Okay, yeah, so there's your homework. Make it happen.